All right, this is Matt Teachout with Intro Stats, and we're looking at a problem in the textbook, section 4C, number 26. So we're looking at comparing, it says the U.S. has the highest teen pregnancy rate in the industrialized world. In 2008, a random sample of 1,014 teenage girls found that 326 of them were pregnant before the age of 20. In 2012, a random sample of 1,025 teenage girls was taken and 334 were found to be pregnant by the age of 20. Let population proportion 1 represent 2008 and population proportion 2 represent 2012. Use a 10% significance level to and the following Teachout printout to test the claim that the population percentage of teen pregnancies in the U.S. is lower in 2008 than in 2012. The claim would indicate the population percentage of the U.S. teen pregnancies is related to the year. Okay, so we're basically testing that the percentage of teen pregnancies is lower in 2008 than it is in 2012. So we see the sample data listed here. Here's our two proportions. And we see here that we have our significance level, critical value, test statistic, and p-value already calculated with Teachout. We could have put these numbers into Teachout ourselves, but the problem has already done this for us. So it's just a matter of sort of understanding these numbers. All right, so if we look at this problem, so pi 1 was 2008 and pi 2 is 2012. Again, the claim was that pi 1 is less than pi 2. The percentage in 2008 is lower than 2012. The null is that they're equal. Now, equal to actually indicates that it doesn't matter what year it is. The pregnancy rate's the same. So that would tell me the year is not related. Equal to always goes with not related. Not equal or different always goes with related. So it doesn't matter what year you're in terms of the chances of a teen being pregnant. So it looks like this is going to be a left-tailed test. Checking our assumptions, they did say this was a random sample. Probably individuals are going to be independent. A small random sample from a very large population of there's millions of teens in the U.S. Chances are we're not going to get teens that are related to each other. Let's see, both samples have at least 10 successes and 10 failures. Yes, they do. Sample 1 had 334 pregnancies, successes, and then 1,025 minus 334 was 691 failures, not pregnant. And then sample 2 had 326 teen pregnancies, so is that 326 successes. 1,014 minus 326 is 688. That's definitely bigger than 10. They told us the z-test statistic is negative 2.10. So remember, that's the number of standard errors. So the sample proportion for group 1 was 2.10 standard errors below the sample proportion for group 2. That's just the definition of the z-test statistic for 2 population. All right, so again, was it in the tail? Well, again, the left tail started at negative 1.645. If we go back to the printout, here's the tail. The left tail starts at negative 1.645. The z-test statistic is definitely not in the tail. Like, it'd have to be around like negative 2 or negative 3 to be in the left tail. This is not. This is actually close to 0. So it's definitely not in the tail, means not significant. So that means that the sample proportions are not significantly different since the test statistic did not fall in the tail, determined by the critical value. That also tells us our sample data does not significantly disagree with the null hypothesis. The p-value was 41.68%. So if the definition of p-value, if the null hypothesis is true, there's about a 41.68 probability of getting the sample data, or more extreme because of sampling variability. P-value was very large, definitely larger than our 10% significance level, so the sample data could have occurred just because of sampling variability. Since the p-value is large, we're going to fail to reject the null, and that means there's not significant evidence to support the claim that the teen pregnancy rate is lower in 2008 than in 2012. In fact, their proportions were very, very close, and the p-value is high, again, not evidence, and could just be the result of sampling variability. So this, if you remember, the null hypothesis is that they're not related. Since we failed to reject the null, it's kind of like we're kind of thinking the null might be correct. So we're kind of indicating here that this data sort of indicates that the 2 years are actually really, really close, and it probably doesn't matter what year we're in. They have about the same teen pregnancy rate. So the year is probably not related to the teen pregnancy.